Hello everyone. In our today's problem, we have to find minimum time to make rope colorful. So Alice has n balloons and she wanted to be colorful. Okay, so she doesn't want to consecutive balloons in together, right? So now Bob is solving this problem, and what Bob is doing, like if he's finding two same colors balloon, he is taking the minimum number needed. So here is the minimum. Here you'll get one colors string, which will represent the colors of balloon, and you'll also find one integer array named needed time, where it represent minimum time needed to remove this balloon. That's it. Now you have to make it unique. Okay. And with minimum time, like for example, if you remove this one, like it have to be minimum time. Okay. Now, if I solve this question, okay. So what the problem says is, the problem says, for example, this is A, right? So A, B, A, C. Okay. So each character represent color. Okay. So here, if you have a look, A and A are together, right? So we have to remove any of A from this string and make it unique, right? Now, for this array, this A, we need one. This B, we need two. This A, three, four, and five. Okay. Now, we have to remove any of A from here. Now we have to have a look which, like, we have to remove any A which will require minimum time. So here among 3 and 4, 3 required minimum time. So we'll remove this one and then A, B, A, C, we can make it, right? So all we have to return this number 3. 3. If we have a look, the minimum number should be 3. Now, here for this ABC, there is no duplicate colors and it's unique, so we don't need any time to remove this one. If we get this one, so it will be more easier to understand. Again, so here for A and A, we have to remove any of them. Now, if we have a look for A and A, one is 1, another one is 2. So obviously we will remove which value is 1, this one. Okay, so we need time 1. Then again, B is unique. We got two again duplicates number or multiples number here, A and A. So here 4 and 1 we require time, right? So obviously we're gonna remove the minimum numbers A. So 1 plus 1, which will be 2. It should be 2. Answer is 2 here, right? That's it. Now, if for example, if I have one test case here. So this one, and if I get the time, yeah. Yeah. Okay. So now it's a bit more interesting, right? Now we have three numbers in together. Here again three numbers in together. Here again four numbers together, right? Now what we can do here, among these three we have to remove any two. So which two will be removing? The minimum two numbers. So here this one, this one. So 8 I removed. Okay. Now among these three, I need to remove two numbers. So 5 and 3 again, 8 plus this A is unique. We'll leave it as it is. Then again, among four numbers or four colors or four balloons, we have to remove three. Only one will be allowed. So we'll keep the maximum one and we'll keep removing the minimum one. So 5 plus 4, 9 and 1, which will be 10. So answer should be 80, 8, 16 plus 10, 26. Answer should be 26. Yeah, it should be 26. Okay. So I hope you got it now. Now, how can you solve this? To solve this is pretty much simple. All we have to do, we have to run a loop, and one loop we're gonna finish this. We're gonna solve this question. So what we'll do, we'll maintain a temp color. So temp initially temp will be the first index A, and temp color will be 3. Okay. Now we will run a while loop here inside of this for loop. So we will be saying if my current color will run this loop from the 1 index. Okay, this one 0. If it is equal to my temp, if it is equal to my temp, then while loop will be keep updating, and it will go there, right? Inside of this, we'll be maintaining the sum of the whole. Yeah, we'll be maintaining sum of the whole string, so which will be 18, and then on the other hand, we'll be maintaining one maximum number. So maximum number will be 10. So 18 minus 10, which will be 8. So means we will be keep tracking the maximum number as we will keep the maximum number in our like current string, and we will be removing the minimum numbers, right? So if we keep adding the whole of string and then minus the maximum number, means if we delete all the minimum numbers, we will be getting 8. And end of this while loop, we will be keep adding this value with our response. That's it. If I like solve this in code, so it will be more understanding. So all we do, we need a response, and the response will be 0. And then character, current color. So current color will be colors of 0, the first one, and I will say current time. Current time will be needed time of 0. That's it. Now I'll be returning response. Okay. Now we'll be running a loop, for loop for int I equal to 1, I less than colors, let's say I plus plus. Then what I'll be saying, and each time I'll be updating the value of my colors. So current colors will be colors of I, and current time will be needed time. Okay, that's it. So each time I'll be updating this one. Before that, I'll be saying while colors of I is equal to current color, then to I plus plus here, and then before that, what you'll be doing, so here we'll be maintaining a sum. So int sum will be, it will start from, let's say it will start from current time, and I'll be maintaining a max number, again current time. Here, what I'll be doing, I'll be saying sum plus equal to my now, plus is equal to time needed to time. That's it. and maximum number will be or max time will be max num or needed time of I. I will keep updating the time of I, and I got some maximum number, and at the end I'll be keep adding it the response. So what I'll be doing, I'll be like reduce the max num from the total sum. That's it. And then again I'll be updating current current color and current time. Yeah, that's it. So in that case, if it is single number, for example, a equal to 5, so current number 5, yeah, then it will be like sum will be 5 and maximum will be 5 as well, as I'm updating here, and 5 minus 5 will be 0. So in that case, there will be no response. Yeah, that's it. And if I run this, it's accepted. If I submit this one, it is accepted, guys. Thank you. And here we can use, this is solution 1, right? Okay, this, okay. Here we can use another thing. If I say, okay, now that's bit that's bit complex, and like it's a brute force approach. But if you think a bit more, like if I tell you, okay, now if I tell you, like you think like this, we can solve this in a one go. Like instead of while loop, we can just use the for loop, right? What we can do, for example, I'll be saying like my I'll be saying if this one is equal to this one, then the response plus equal to the minimum number. Okay, minimum number of I or j. Okay, so here, if you have a look, response plus equal to minimum number of 3 and 5, which will be 3. So I'll be adding the 3. 3 plus, okay. Then again, the I go there and it will again compare with I minus 1. It is same. So it will get the minimum number, okay. 5 plus 5 or 10. So minimum number is 5. Okay, it will be adding. Now it will go B. A is not same as B. So it will go here. It is same. So the minimum number between 7 and 5 will be 5. Then again it will go there. So minimum number between 5 and 3 is 3. On A is not equal to B, so it will go one step ahead. B is not equal to A. Here B is equal to B, so the minimum number between 5 and 4 will be 4, plus here B is equal to B, so the minimum number between 5, 4 and 8, it will be 4. Now if you look, we are adding 4 two times between these three numbers, but it shouldn't be like this. It should be only 5 and 4, not 4 two times. There is like we can't reduce one value two times, right? we should get rid of these two numbers. So here it is 8, but it should be 9, right? Now, to solve this problem, to solve this scenario, what we can do, at the same time, while we are taking the minimum number, we can swap this one, right? For example, when I came here, it is like five, minimum number is five, minimum number between 5 and 4 is 4. What we will be doing, we'll take the minimum number, it is, at the same time, we'll be swapping this one. So my ith value will be the maximum number. Why we are doing like this? So that if in near future or our next value is same, we can compare with the maximum number, right? Because if we again compare with the minimum number, it is already taken, right? So what we'll be doing on that position, we'll be always keeping the maximum number, which one is 5, right? Now we will be comparing with 8 and 5. So the minimum number is 5. Again, here we will be comparing the maximum number, and here maximum number is 8, so 8 will be staying on his position. Here we will be comparing, and among 8 and 1, obviously 1 is smaller number, and this should be the answer. Okay, so we will be keep updating the response, and at the same time we will be keep updating the maximum number. So if I implement this in theory in my code, it will be if if colors of I is equal to colors of I minus 1, then my response plus will be minimum number of needed time of I, or needed time of I minus 1. That's it. Then what I'll be saying, like I'll be keep updating my I'll be keep updating my needed time of I will be maximum between these two numbers. Okay, so I'll keep updating the maximum number, pushing the maximum number forward, so that in future I can compare with the maximum number, and minimum number I already taken, means like I've already destroyed this like row, and if I run it, it should get accepted. Yes, it is, and if I submit it, it's accepted, guys. Thank you so much.